type of thing that a traditional sysop wouldn't really think about. But as developers, we've learned the rule that testing makes our lives easier. We know that we're supposed to test even if we're not doing it. A lot of the operations world is just starting to learn this lesson. And I'll argue that one of the greatest things we developers can bring to operations staff is sort of this testing culture that Python in particular tends to be reasonably good at. So hopefully that gives you some of the sort of basic ideas of what I think DevOps is about. This application of the principles of development to the role of operations. So I want to spend the bulk of this talk, that was just me sort of clearing my throat. Now that I'm warmed up, I want to spend the bulk of this talk going into what I'm calling, somewhat tongue-in-cheek, the cardinal virtues of DevOps. I need to take a little sidebar here and point out this gentleman here is Eric Holscher. A good friend of mine also lives in Lawrence, Kansas. Much of this talk has come out of a series of conversations that Eric and I have had over the last year or more, just sort of about this, these ideas of what is DevOps, what does it mean to be sort of to have the operations role being pushed down onto the developer, or maybe vice versa. And much of this talk wouldn't have been possible sort of without his thinking and without sort of using him as a sounding board. And I won't respond to rumors that alcohol may have been involved in these conversations. So the cardinal virtues of the DevOps engineer: laziness, impatience, hubris. Does anyone recognize these? Yeah, these are Larry Wall in the Perl book, the Camel book. I don't even know the title of the book. It's the O'Reilly Camel book. It's the Camel book. What is the title anyway? Anyone? Anyway. Programming Perl. It's a classic. It's a wonderful book. Even if you're not a Perl programmer, it's well worth reading. He lays out in that book what he calls the cardinal virtues of the programmer: laziness, impatience, and hubris. And he goes on to explain why these traits that on the surface sound somewhat derogatory are in fact really positive traits when you look at it through a certain light. And so I want to reapply these using what we know as developers, using everything we've learned as web developers. I want to reapply that to the idea of operations, because I'll argue that these same rules apply perfectly, and in fact they map really well onto deployment, onto operations. And along the way I'm going to talk a little bit about some tools that I use that I think sort of embody these principles. So laziness. So Larry says that laziness is this quality that makes you expend a lot of effort up front to avoid work later on. Laziness isn't about avoiding work necessarily, it's about recognizing a repetitive task and pre-optimizing for it, doing some work, extra work up front to avoid having to do more work later on. And we've all done this. We've all spent a day on a task that we could get done in an hour because we know we'll have to do that task 30 more times. And we know that over time, it'll be quicker over time to sort of do something more general up front now. In other words, it's sort of this, it's like an average laziness. We strive to achieve the highest average laziness over a long period of time, even if it means momentary bursts of productivity now. And this is usually translated in development to something along the lines of DIY, don't repeat yourself. The idea that if we know we have to do some repetitive task, or if we're going to have to write the same code over and over again, we should refactor it to the point that we're able to not repeat ourselves and use it over again. Martin Fowler's rule about refactoring is maybe the classic sort of laziness in action rule. Fowler says the first time you do something, you just do it. The second time you do it, you kind of bite your tongue, do it anyway. Third time, refactor. Really good rule to sort of sum up, when you can be lazy and when you can't. applied to deployment, applied to operations, it's pretty clear that the laziness principle tells us that we want to automate as much as possible. Rather than doing something directly on a server, better to write a script to do it and then execute that script. That way, if we need to do it again, we can just sort of, hit the button and do it again. You never really know as an operations engineer when this little task you need to carry out is something you're going to just do once, you're going to just do twice, or you're going to do hundreds of times. So it's a good idea to have sort of tools ready and mechanisms in place that you can easily and quickly automate whatever you're doing. And of course, by putting everything into a script, we also sort of gain those best practices we've learned as developers. We can check that script into source control. We can institutionalize that knowledge. Now that little, that complicated shell pipeline that I wrote to extract some statistics from a log file is something that anyone with access to the servers can run. My typical rule these days is I do everything in my power to avoid operating directly on the server. I try really hard not to do anything directly. I write all of my tasks into a script, and then I execute that script. That means it's incredibly easy for me to run that just once on one server, or once across all my servers, or every day, or et cetera. It makes it very easy to be flexible about when and where I run that task. My tool of choice here is something called Fabric. Who's been exposed to Fabric here? Great tool if you do any sort of system scripting. It's a very small, lightweight Python tool that lets you execute code on a single server or across dozens of servers with very little overhead. It's very simple. There's really not a lot to it. It's up to you sort of to build higher level abstractions on top of it. If you're familiar with automation tools like Capistrano from the Ruby world, Fabric is maybe 10% of Capistrano. But it's the really good 10%. It's the best 10%. Here's a sort of semi-contrived example fab file. Fabric calls its scripts fab files. And you can see it's just Python code. You define some functions. They can take arguments. And you get a few commands. You get a run command, which runs a command remotely on the server as whatever, it executes all its commands over SSH, so as whatever SSH user you want. There's a sudo command, which runs things under sudo. There's a few higher level abstractions that let you check if files exist remotely, rsync directories locally, remotely, put files, get files. But it's really very, it's very basic. Run this command over there, run this command locally, that sort of stuff. What's important about this is that it's just Python, right? So what starts out is just a series of run commands. We can use all these tools we already know as Python developers to refactor, to introduce classes as necessary. We can call APIs. We can do whatever we need to do. It's just Python code. And Fabric takes care of running this on one server, on all your servers, or however you want to do that. And you can sort of invoke the stuff from the command line. It's very lightweight, very easy to use. As I said, I put everything that I do into a fab file. I pretty much get in the habit of trying to avoid typing SSH at my shell and instead putting into a fab file. It takes 20% longer, but it probably saves me 20% every day from there on out. Highly recommend, if you have to interact with remote servers, teach yourself Fabric. It'll take you 5 minutes to learn, and you'll have a nice little tool in your arsenal. The other tool that I think the lazy operations engineer relies on are a set of tools usually called configuration management. The basic idea behind configuration management tools, let me ask, is anyone here already using a configuration management tool? What are people using? Shout it out. Puppet? Okay. Right, because you work at Google, and Google's special. Ooh. Yeah. Yeah, you're special, whatever. My friend James likes to say he can count the number of companies like Google on one finger. Right, so who here is responsible for any sort of deployment operations role and isn't using configuration management? Wow, okay, well, I'm preaching to the converted then. For those who will at some point merge into this role, let me give you the brief outlines. The basic idea behind configuration management is that rather than setting up a server by hand, rather than SSHing in and editing files in etc and sort of starting services and creating users, that sort of thing, you actually tell a configuration management tool how you want your server to be set up, and the configuration management tool goes and figures out what it needs to do that. And configuration management tools usually understand how to do things differently on different OSs, so it knows that on Debian I add a user using the add user command, and on Red Hat it's the user add command, or maybe it's the other way around. I can never keep those two straight. And it understands that on Mac there's this whole net info crap. It knows how to sort of deal with doing different things on different machines. Configuration management tools also tend to be declarative rather than imperative. So Fabric is imperative, right? Do this, do that, do this, do that. And you can use something like Fabric to set up, to provision a new machine, create a type